Hi everybody, welcome to Edu-Malanga, where we do maths tutorials for South African matriculants. What we're going to be covering today is functions and inverse functions. These are essentially graphs. So what I'm going to do is I'm going to give you an introduction video on this, and then we'll follow through with examples in the next video. What a function is. As we know, as we should know, is it's a rule or a relationship, right? A rule or relationship between the x and the y values. Between two sets. What a function has, has a domain and a range. I'm going to explain to you what a domain is. We already explained above that a function is a relationship or a rule between the two sets. So one part of the set is x values and the other part of the set is y values. So the domain then becomes how far x goes. Okay, so it's all the x values. The range becomes the y values. So how far the y values go. And essentially what we get is every element of in the domain corresponds to an element in the range, and therefore on a Cartesian plane or an x and y axis, which I'll draw very roughly, but I think we understand the concept, corresponds to one point, and on that point we've got an x value and a y value. Okay, and that is the x value belongs to the domain and the y value belongs to the range. So an example of this relationship or function is y is equal to mx plus c, which most of us are familiar with. But I'm going to explain it so that we all understand. Y would be all of the elements in the range, right? X would be all of the elements in the domain, and we substitute y and x every time we need to get the corresponding value, depending on what we have. M, which often equals to y over x, or what we call y2 minus y1 corresponding to x2 minus x1. Essentially how it slopes, how the graph looks. And C then becomes the intercept, where the graph crosses the axis. How we get this, or how we prove it, is if y is equal to mx plus c and x is equal to 0, what we're going to get is y is equal to c, because we substitute the 0 into this part of the equation, and therefore we get the equation y is equal to mx plus c as what we generally understand to be a function. Okay, I'm going to give you an example to explain what a one-to-one function is. So one-to-one function, essentially it's as the English explains, or as the sentence explains. It means that one element corresponds to one element. One element in the domain corresponds to one element in the range. An example is a straight line. Okay, if I have a function fx, I call my function fx, which is equal to y, right? X plus 2. Remember, this is the function. Okay, and remember that this is the domain, and then that is the range. What we get in our function, which was, I'm going to write it down here. Sorry for moving the screen. I'm going to write it down here so that we just remember what it was, is equal to x plus 2. Okay, so in this function, I'm going to substitute a couple of values in for x. I'm going to substitute x equals to 1 and x equals to -1. Okay, so this is all just different values of x that I'm going to substitute into this equation. At f, function f at 1 is equal to, I place, so I can just say y there again, and I substitute 1 into here. So I'm going to substitute a 1 plus 2. Okay, So 1 essentially is no negative, there's nothing. 1 plus 2 is 3. And then at negative 1, what we get is that y is equal to bracket negative. Okay, so this is negative as I was explaining. So we're going to get 1. Negative 1 plus 2 is 1. Okay, so I'm going to try and plot this graph so that we can see what I am talking about. And I can show you the one-to-one relationship I am talking about. So if I had to draw here a Cartesian plane or an x and a y axis, and I'm going to call this my y axis and this my x axis, and I'm going to take each and every block or each and every straight line to be 1. So at x is equal to 1, y is equal to 3. So at x is equal to 1, y is equal to 3. There is the point I plot. Okay, and at x is equal to negative 1, y is point over here. I don't like the pen I'm using. Awesome stuff, awesome sauce. Okay, this point over here is x negative 1, y 1. Okay, and I'm going to draw a squiggly straight line, but we get the point. And there is my graph. So what we see on this graph is that there is no place where two x values give you the same y value. So if I go here, I get one y value. I get here, I get one y value. And we call this a one-to-one relationship. And I'm going to show you one of the tests that I used to prove that it's a one-to-one relationship. And you must use this because it's quite an easy tool. I think you should use it because it's quite an easy tool to prove this. Okay, it's called the vertical line test. So I draw a vertical line, vertical being parallel to the y-axis. And if I draw a vertical line down and it only intercepts my graph at one point, it then qualifies to be a function. Okay, it qualifies to meet the definition of a function because it only crossed the graph once. So now let's take an example of a parabola. Okay, we know the relationship between a parabola. I'm going to give you this example, but a relationship between a parabola is often described as ax squared, right? So what we get here is we have our a as being 1 and x squared and y is that. Okay, so I'm going to plot this so I can show you guys how we're going to see whether or not a parabola is a function and what kind of function it is. So we said a straight line was a one-to-one function simply because it went one x value corresponded to only one y value. Okay, so then I'm going to call this graph here hx because we already did fx in the previous table, and I want to call it x squared, and then I'm going to substitute again values of x. So at 1, x is equal to 1, I substitute my 1 squared is equal to 1. Why is 1 squared equal to 1? Because it essentially is 1 times 1. Okay, then I substitute, for instance, a 2. Okay, interest sake, 2 squared, which is equal to, again, 2 times 2, I get 4. And then at value negative 1, just like we substituted in negative 1, 1, 1 for fx in the previous graph when we did the straight line graph. Negative 1 times negative 1, the negatives become positive and we get 1 times 1 is 1. So essentially I'm going to plot this for you guys, and I see already, just noticing it myself, is that I've got different values of x corresponding to one value of y. What do we call that? So we can't call it a one-to-one relationship. So we now coin it the new term, many to one relationship. Okay, this is very important for you to understand because it describes essentially the function you're working with, if it is a function. So we're still going to test whether it is a function or not, because I gave you guys in the previous slide how to test a function. Okay, so at 1 it is equal to 1, so I go 1, 1. It's so easy to plot it when you've got a graph, so if you can get graph paper, it would really help. At 2 I give it 4, so at 1, 2 I get 4. Okay, so 2 and 4, and then at negative 1 I get 1, so negative 1, 1, and then so draw like a smiley face. It goes up, and we get the awesome graph of hx, the relationship hx. Okay, so remember I told you guys that in order to test whether it is a function, I draw a straight line. So I'm just going to draw it wherever I want to draw it. It crosses the graph once. What is that? A function. However, not all two different values of x corresponds to one value of y, and therefore it has a many to one relationship. Okay, I'm going to continue on the next page. So the vertical line cuts the graph of hx only once, therefore we said it was a function. So hx, which is equal to x squared. And then we also said that we need to check the many to one relationship that we said it already has. Go down, like I taught you in the previous slide. So what you get is same thing, and I'm going to redraw the graph. Okay, not perfectly, but we get the relationship. So I've drawn a horizontal line crosses a vertical line crosses once. Horizontal line is one that is parallel to our horizon. It crosses twice, so what we call that is a many to one relationship. Okay, it helps us decide what kind of function we have because we've said it's a function. So I have come to the end of explaining functions, but what I will do in the next video, which you should check out, is an explanation, an example of the function itself, and how we can do an example of a question that you could be asked in your examinations or tests, and we will do a parabola and a straight line so that we can understand how to apply it in our tests. What I will also do after that is then explain the inverse functions. Thank you very much. Do tune in next time, and remember to subscribe, share, and if you ever are confused, come back to our videos. You can also download our videos, and let's pass maths, guys.